Welcome back, students. I hope you all are fine. Today, our topic is about the applications of the normal curve. As previously we have discussed how to interpret the scores, we will discuss about the applicability of the normal curve. There are so many applications of the normal curve in the educational measurement and psychology or sociology. A few we will discuss. First of all, I will discuss here to compare the scores of two different tests. Student is having the two different test scores and how to compare those test scores. That is one of the applicability of the normal curve. A student has secured 70 marks in the psychology and 60 marks in the sociology, and if the mean and SD of the psychology test is 75 and SD is 10, though, and then that of the sociology test the mean is 50 and the SD is 6, in which subject the student has performed better. We as I've already told you about the interpretation of the scores. The raw score tells us the wrong information many times. Here, if we compare these two raw scores, that is the raw score of the psychology test and the raw score of the sociology test, the layman will say that student has performed better in the psychology test and than that of the sociology test. But it's not how we compare the two different scores. First, we have to convert them into the standard score, and one of the standard score which we will use here is the z-score, as I have already told you about the standard scores in the previous video lectures. So to find out the z-score of psychology test, we have given the raw score, that is 70, and we have given the mean, that is 75, and we have given the SD, that is 10 of the psychology test, and we have to find the standard score, that is the z-score we will find, and this is the raw score, this is the mean divided by the standard score. Here the raw score is 70, applying these in the formula, and the mean is 75, that is 70 minus 75 divided by 10, that is the standard deviation of the test, and when we calculate, the standard score comes out to be minus 0.5 SD standard deviation, as here the negative is bigger than the positive, so it output comes out to be the negative. And next we have the sociology test. In sociology test, candidate has secured 60 marks, that is the raw score, and the mean of that group is 50 and the standard deviation of that group is 6. So we have to find out the z-score here. Here the raw score is 60 and the mean is 50, standard deviation is 6. Putting these values in the formula, we get the z-score, and the z-score of the sociology is 1.6 times SD. You can have a look on both the values. Here minus 0.5 SD and here it's 1.6 SD. It's evident from these two values that candidate has performed better in the sociology test than in the psychology test. Apart from these calculations, you can also calculate it from the normal probability curve, as we have already discussed in the previous lectures that the normal probability curve is having the mean 0, that is the center point is 0, and the SD 1. So from the right hand side we go on adding the 1, and from the left hand side we go on subtracting the 1. Here in the psychology test there is 75 is mean and 10 is standard deviation, so at the center of this we will have the 75, which is the mean of the group, and then we will add the standard deviation from right hand side, and we will subtract the 10 standard deviation from the left hand side. From this you can see that where the 70 score will lie. 70 score will lie between the 60 and 75. It may lie here. We can say that from this graph the candidate has secured marks below average, which is given here 75, and he has secured the marks below average. Next is sociology test, and in sociology test we have the mean 50 and the standard deviation is 6. So the mean 50 is in the middle, and then we add or subtract the 6 from mean, and the other observations come out to be like this. And then we will see that this score of the sociology of the candidate is 60. Where the 60 lies here, it lies in between 56 and the 62. It may lie here in between these two. We can say that in sociology the candidate has secured marks more than that of the average candidate. Now you can compare the two scores. In the psychology case, the candidate has secured the marks below the average, and in the sociology case the candidate has secured the marks above average. If we go on interpreting the scores on the RAS score, that will give us the wrong information that the candidate has performed better in psychology than in sociology. But when we standardize these RAS scores, and we get that the candidate has performed better in sociology than the psychology. And next application we will discuss is to determine the percentage of the cases which lie within the limits or the scores. In the question there will be given the limits or the two scores, and between them you have to find out how much percentage of the cases lie. I have already shown this normal probability curve is having the unit, that is the standard deviation, and first we have to convert every score in the standard score, then we can find it in the normal probability curve. And I have already told you in the previous video lectures how much percentage of the cases lie between plus minus 1 SD or plus minus 2 SD, or between 1 and 2 SD on the both sides, or between mean and 1 SD. And we have discussed it in the previous video lecture. If you have not watched that video lecture, link of that video lecture is given in the description box. And now here we have the question that in the normal distribution the mean is 60 and the standard deviation is 6. Find out what percentage of the cases lie between the two scores, that is 50 and 70. Here we have a distribution where the mean is 60 and the standard deviation is 6, and we have to find out the cases between these two limits or between these two RAS scores. First of all, we have to convert these RAS scores in the standard score, that is we will convert it into the Z score. And here we have given the RAS score, first RAS score is 50 and the mean is 60, standard deviation is 6. Put these values in the Z score formula, we get Z score as minus 1.6 SD. So it's here that 50, when we convert it in the standard score, it comes out to be minus 1.6. And what about RAS score 70, and the mean of the distribution is 60 and the standard deviation of the distribution is 6. Putting these values in the Z score formula, calculate the Z score, and we will get a standard score for the RAS score 70 is plus 1.6 SD. Now we have to find the percentage of the cases which lie between minus 1 SD and plus 1 SD. Let's check it from the normal probability curve. This is the normal probability curve, and you know that how much percentage of the cases lie between these. We have already discussed it, and now we have to check the percentage of the cases from minus 1.6 SD to plus 1.6 SD. Where does minus 1.6 lie? Minus 1.6 may lie between in between this minus 1 and minus 2, in between somewhere here it may lie. And where does the plus 1.6 lie? It may lie somewhere here. It's more than the half of the two. We know between the minus 1 and plus 1 SD how much percentage of the cases lie. It's 68.26%, but we have to find the percentage of the cases which lie between minus 1.6 to plus 1.6 SD. We know that there percentage of the cases which lie between minus 1 and minus 2 SD and plus 1 and plus 2 SD, it's same from both the sides, 13.59. Here this portion is 13.59 and this portion is also 13.59% cases lie in between these two. So I have written plus minus 1 and plus minus 2, there lies 13.59% of the cases. So we have to find how many cases lie from 1 to 1.6 SD, that is from 1 to 1.6 SD, somewhere between here and also somewhere between here. When we half this portion, that will come out to be 1.5. When we half this 1 plus 2 divided by 2, that will come out to be 1.5. We will divide this in two portions, that will come out to be 6.79%. This portion is 6.9 and this portion is 6.9, and similarly from here if we half this portion will be 6.79 and this portion will be 6.79. The whole portion from this to this is 13.59 and from this to this is 13.59. But we have to find till 1.6. Okay, we have to find 1.1 more than 1.5. And what's the distance between 2 to 1? There is 13.59, and if we divide it into 10 similar parts, then we will get each part as 1.359 cases. So from 1.5 to 1.6 on both sides, from the positive side and from the negative side, we will get the cases of 1.359. Now what will be the percentage of the cases in between 1 to 1.6 in this? It is the case percentage of the cases between 1 to 1.5, and we will add it the percentage of the cases 1.5 to 1.6. Here it is 6.795, so I have written here 6.795%, and here it is 1.359%, and that will come out to be 8.154%. And if we round out this figure, that will be 8.15%. This means that if here it is 1.6 and here from this side it's 1.6, it's plus 1.6, it's minus 1.6. The distance between minus 1 point to 1.6 and distance between 1 to plus 1.6, percentage of the cases here is 88.15. We have to find the percentage of the cases between minus 1.6 to plus 1.6. That means we have to find the percentage of the cases from here and from this side here. We have to find the percentage of the cases from minus 1.6 to plus 1.6. We already know that the percentage of the cases from plus minus 1, that is equal to 68.26. We will add to this the percentage of the cases from this side minus 1 to minus 1.6 and from this side plus 1 to plus 1.6. That will come out to be 68.26%, that is plus minus 1 SD, and from this side it is 8.15 percent, and from this side it's 8.15%. After adding up these values, we will get that from minus 1 SD, from minus 1.6 SD, that is from this portion to this portion, plus 1 SD, how much of the cases lie? 84.56%. That means from this portion to this portion, there as the number of the cases which lies is 84.56%. This means that between the value raw score 50 and raw score 70, how much percentage of the cases lie? 84.56% of the cases lie. I hope you have understood these two applicabilities of the normal probability curve, and you have to do this exercise. First is that a student has secured 40 marks in the mathematics and 70 marks in science if the mean and SD of the mathematics test is 75 and 10 and the science test is 50 and 6. In which subject the candidate has secured the better marks or performed better? That means you have to convert these raw scores in standard score, then you have to compare these two scores. From raw scores, it depicts that in science candidate has performed better, but you have to check it by converting them into the standard score. Next question is, in a normal distribution where the mean is 80 and the standard deviation is 10, find out what percentage of the cases lie between the scores 50 and 70 and between the scores 60 and 90, between the scores 45 and 85. You have to convert these scores also into the Z scores and then find out how much percentage of the cases lie between these two. I will be back with the new video lecture soon. Till then, Stay safe, stay healthy, stay motivated. Stay tuned to the channel. Have a nice day.